Peak Resources recently released a preliminary feasibility study and a maiden ore reserve for the company's 100% owned Ngualla rare earth project in Tanzania. The study confirms that Ngualla is an economically robust project with the largest and highest grade ore reserve of any of the rare earth development projects. Based in Perth, Western Australia, Peak's Ngualla rare earth project is located in the established mining jurisdiction of Tanzania, the third largest gold producer in Africa. Ngualla lies 150 kilometres from the airport and major railhead at the town of Mbeya. The rail links Mbeya to the deepwater port in the commercial capital of Dar es Salaam. Peak Resources has rapidly progressed the Ngualla rare earth project from virgin discovery in August 2010 into one of the largest and highest grade rare earth deposits in the world. Rare earths play a vital role in today's modern world. The clean energy and digital technology sectors will drive an ever-increasing demand for rare earth resources. Hybrid and electric vehicles, wind turbines, and energy-efficient lighting all rely on the properties of rare earth elements. The Ngualla rare earth project is centered on a large circular carbonatite pipe. An alteration halo forms the ring of hills that surround the intrusion. The carbonatite is concentrically zoned with a later stage core 1 kilometre in diameter. Rare earth mineralisation is hosted within this central core, known as the Southern Rare Earth Zone. Peak's focus is on the development of the weathered bastnäsite zone mineralisation in the centre of the Southern Rare Earth Zone. High-grade mineralisation occurs from surface in the weathered bastnäsite zone. Above a 3% cut-off grade, the weathered bastnäsite zone resource is 21.6 million tonnes at 4.54% rare earth oxide, for over 980,000 tonnes of rare earth oxide. The bastnäsite zone is included within the greater Ngualla resource of 4.4 million tonnes of contained rare earth oxide, making it one of the largest rare earth deposits outside China. The bastnäsite zone mineralisation has the lowest uranium and thorium levels of any of the large rare earth deposits of 14 and 51 parts per million respectively, and is a key advantage of the project. The deposit also contains significant grades of the higher value critical rare earth elements currently in high demand. The combination of Ngualla's unique rare earth and host rock mineralogy distinguishes it from other rare earth deposits and has enabled Peak to develop a simple, low-cost, three-stage metallurgical process. Beneficiation utilizing wet magnetic separation and flotation physically concentrates the mine feed to produce a threefold rare earth upgrade while reducing the mass by 78% at 70% recovery. Peak has successfully demonstrated a simple hydrometallurgical flowsheet to recover, purify and concentrate the rare earths into a form suitable for feeding into the separation plant. A third stage of purification and recovery by solvent extraction of 4 high-purity separated rare earth products adds significant value to the Ngualla project and allows access to wider end-use markets. Peak is one of only a few rare earth companies to have practically demonstrated a metallurgical process from mineralisation through to high-purity separated rare earth oxide products. Peak released the results of a preliminary feasibility study and economic assessment for Ngualla in March 2014. The study was accompanied by a maiden ore reserve estimate of 20.7 million tonnes at 4.54% rare earth oxide for 941 tonnes of contained rare earth oxide. Sophisticated engineering simulation and mass balance modelling of the demonstrated metallurgical process supports the detailed cost estimates in the study, which include a post-tax and royalties NPV of over $1 billion. The Ngualla mine will consist of an open-pit operation with a low strip ratio producing 360,000 tonnes of ore per annum to support an initial mine life of 58 years. Components of the recovery circuit and rare earth separation plant will be constructed of fiberglass reinforced plastic and will be built off-site in modular form. Steam produced as a byproduct of the sulfuric acid plant will be used to generate over 50% of the operation's electricity via a steam turbine, with waste low-pressure steam reused to heat the leach tanks, reducing the on-site fuel requirements and operating costs by over 50%. The rapid development of the Ngualla project from discovery to completion of the preliminary feasibility study in just 3.5 years is without comparison in the rare earth industry. Robust project economics, low capital and operating costs, and a long mine life all help to position Ngualla at the forefront of potential rare earth producers. Ngualla's value drivers are the high-value praseodymium, neodymium and mid-heavy high-purity oxide products, which together make up 83% of forecast annual revenue. Based on the positive outcome of the preliminary feasibility study, the project is expected to move rapidly into the full definitive feasibility during the third quarter of 2014 and provide a clear development pathway to advance Ngualla into a low-cost, long-term rare earth producer in 2017.